In 1994, Jupiter suffered an unprecedented impact. It was an impact of unprecedented scale. A comet, Shoemaker-Levy 9, didn't stand a chance. Before it could even threaten Earth, Jupiter's immense gravity captured it. The behemoth tore the comet into 21 separate fragments. These pieces then slammed into the gas giant one by one, a cosmic barrage traveling at 60 kilometers per second. It packs a punch equivalent to 6 trillion tons of TNT. The energy released was staggering, more than all the nuclear weapons on Earth combined. The impacts left dark scars on Jupiter's clouds, some larger than our entire planet. For a moment, humanity saw firsthand just how violent the cosmos can be, and how fortunate we are to have this colossal guardian. The guardian that shields Earth from the equivalent of 3,000 atomic bomb blasts every second, 4.5 billion years ago. It is, without a doubt, our most reliable protector. But this guardian has a dark past. Rewind 4.5 billion years, and you'll find that this very same planet was once a rampaging demon that nearly destroyed the entire solar system. This behemoth, with a diameter of 1,400,000 kilometers, is so vast you could fit 1,321 Earths inside it. Its role as a cosmic shield is no exaggeration. Without Jupiter, astronomers calculate that the probability of a large celestial body hitting Earth would increase by 1,000 times. The 1994 impact wasn't a one-off event. In 2009, an amateur astronomer spotted a new dark patch. It was confirmed to be another impact scar, this one the size of the Pacific Ocean, from an object just a few hundred meters wide. Over billions of years, Jupiter has acted as a gravitational vacuum cleaner, absorbing countless asteroids and comets. But its protection goes beyond direct impacts. In its orbital path, 60 degrees ahead and behind, lie the Lagrange points. Here, Jupiter has gravitationally locked over 12,000 Trojan asteroids, a massive swarm that could otherwise pose a threat. And then there's its magnetic field. It's an invisible shield of immense power, 20,000 times stronger than Earth's. If we could see it with the naked eye, Jupiter's magnetosphere in our night sky would appear larger than the full moon. This field deflects a constant stream of high-energy cosmic rays and deadly radiation, powerful enough to tear apart radio signals, ensuring they never reach us. It is the ultimate planetary bodyguard. But it wasn't always this way. In the chaotic dawn of the solar system, Jupiter was the primary agent of destruction. As the nebula of gas and dust began to collapse, rocky planets started to coalesce in the inner solar system, while the solar wind blew lighter elements away. Jupiter, which should have remained in the outer solar system, began to migrate inward, driven by its terrifying gravity. When it reached the vicinity of Mars' orbit, its gravitational influence was catastrophic, disrupting the entire disk of material. Mars, which had the potential to grow to 1.5 times the size of Earth, was starved of material, left with only 10% of Earth's mass. Without this interference, Mars might have been massive enough to maintain a magnetic field, a thick atmosphere, and liquid oceans. The danger was even more immediate for us. Jupiter continued its death spiral, accelerating towards the Sun. Had it reached our orbit, Earth would have either been captured as a moon, or flung out of the solar system entirely. Salvation came in the form of Saturn. The two giants fell into a perfect orbital resonance, a gravitational dance that halted their inward march. Joined by Uranus and Neptune, they stabilized the entire system, pulling everyone into the orbits we see today. Our existence is owed to this cosmic near-miss. The extremes of Jupiter defy human imagination. That iconic great red spot on its surface is a superstorm that has been raging for at least 400 years. Its winds howl at over 500 kilometers per hour, and the storm itself is large enough to swallow 3 Earths whole. But the surface is just the beginning. Descend into Jupiter, and deep in the atmosphere, the gas is compressed into a vast global ocean of liquid hydrogen. Go deeper still, and the pressure creates something that doesn't exist on Earth, metallic hydrogen, hotter than the sun's surface, which conducts electricity like a metal. The weather here is terrifying. Lightning flashes with 10,000 times the energy of a bolt on Earth. The thunderclouds aren't made of water. They're composed of toxic ammonia ice. The auroras at its poles are 300 times more powerful than our own, releasing enough energy to destroy an unshielded space probe in minutes. From the Kepler Space Telescope to the Juno probe, the more we learn about Jupiter, the more it seems the secrets of the universe are hidden within its swirling clouds. Despite its immense size, Jupiter is technically a failed star. If it had gathered about 80 times more mass, its core would have ignited nuclear fusion. The solar system would have had 2 suns. This duality defines Jupiter. It is a meat grinder that devours celestial bodies, and yet, it is also a creator god. In its 4.5 billion year history, it has shielded us with its own violent nature. But that same chaos may have delivered the very ingredients for life to a young Earth. Ancient cultures, like the Chinese, called it Sui Xin, the year star, and considered its appearance a sign of fortune. It's a beautiful paradox. A world like this is incredibly rare, found in less than 0.01% of star systems in the Milky Way. So when we gaze at Jupiter's clouds, beautiful as an oil painting, we're not just seeing storms moving at 1,500 kilometers per hour. We are seeing the primordial imprint of our own origins, a testament to the chaos and luck that allowed life on Earth to begin. Jupiter's unique role prompts a larger question: are we alone? The cosmos is filled with even stranger phenomena. In 2019, astronomers discovered something new: odd radio circles, or ORCs. Enormous, faint rings of radio emission, up to 1 million light-years across. The largest is 3 million light-years in diameter, completely invisible to the naked eye. Their origin is a complete mystery. Some theories suggest they are shock waves from colliding supermassive black holes. Others propose they are related to intense bursts of star formation, and some speculate they could be a form of cosmic beacon. This echoes the discovery of fast radio bursts, or FRBs, first seen in 2007. These are incredibly powerful bursts of radio energy that last for only a few milliseconds. Theories range from magnetars to the tantalizing idea that they are deliberate signals from an alien intelligence. History is full of such moments. When new phenomena like pulsars were discovered, the first thought was often aliens. But time and again, they turned out to be natural, albeit extraordinary, phenomena. Our own attempts to reach out, like the Arecibo message, have barely scratched the surface of cosmic distances. So unless an alien civilization actively visits us, we remain, for all practical purposes, alone. If the speed of light is the absolute cosmic speed limit, then perhaps the question of whether aliens exist doesn't even matter. No civilization could colonize a galaxy, their influence limited to a local bubble. In a galaxy with 100 billion stars, dozens of civilizations could exist in total isolation. For us, fully developing our own solar system could take tens of thousands of years. Whether humanity can even last that long is the biggest question of all. While Jupiter failed to become a star, the universe contains power sources that make stars look like candles, black holes. Most people think of a black hole as a cosmic vacuum cleaner, greedily swallowing everything that comes near, including light. But to astronomers, they are also immense sources of potential energy, with their gravity acting like a cosmic telescope. In 1969, Roger Penrose devised a method to extract energy from a rotating Kerr black hole. The key is a region called the ergosphere. An object can enter it, gain energy from the black hole's rotation, and still escape. The process involves dropping an object in, splitting it, and ejecting one half with more energy than it started with. The black hole acts like a giant cosmic generator. Theoretically, this can convert over 20% of mass into pure energy. For comparison, nuclear fusion is only 0.4% efficient. The SETI program has identified around 20 stellar candidates that show unusual dimming, possibly from Dyson spheres. But for our solar system, building one would require dismantling Jupiter, causing gravitational chaos. Even black holes are not eternal. Stephen Hawking proposed that they slowly evaporate through Hawking radiation. Supermassive ones will take trillions of years to disappear. This theory, however, remains unproven. The black holes we can study are too far away to detect this faint radiation. It remains one of science's great unsolved mysteries. From cosmic violence to steadfast guardian, Jupiter embodies the forces that shape our universe, the failed star that allowed our world to live.